Hello, everybody. Welcome to 321 Gang's webinar, Global Configuration Management, a game changer for requirements management. Thank you for joining us. My name is Kara Rawlings, and I'd like to tell you a little bit about 321 Gang before we get started. 321 Gang are a Platinum IBM business partner and a Scaled Agile Bronze training partner. The Gang are the continuous engineering experts and an industry leader in scaling lean and agile practices. We offer our clients expert IBM and SAFe consulting services, training, and software tooling solutions to accelerate and drive results in the most complex, highly regulated systems and software engineering environments. 321 Gang's engineering expertise can help, whether you're facing regulatory, economic, or technological challenges. 321 Gang offers industry-focused training and consulting. Talk to us today and learn how we can help deliver the solutions your team needs. Please take note of the question box in your control panel. We'll be accepting questions throughout the presentation, and we'll be addressing them at the end. 321 Gang's Peter Lucky is our presenter today. Peter is a senior solutions consultant here at the Gang. He is a Scrum Master and a certified SAFe program consultant, and he has Atlassian certifications in Jira and Jira Align. He received his master's degree in computer science from Purdue University. Peter began his professional career in IBM's Federal Systems Division as a programmer, where he concurrently worked as an adjunct associate professor at the State of New York, Binghamton University, and he taught software engineering and publishing a number of papers on the subject. Upon moving to Canada, he became the technical manager of IBM's Rational Software Development Environment for Rational Canada. Peter has been involved in selling and supporting engineering tools and the processes supported by these tools throughout his career. These processes include topics such as Agile, MBSE, and SAFe. And that concludes our introduction, and Peter, the floor is yours.
All right, thank you very much. So let's jump right into it here. To fully support requirements management best practices, a tool needs to support traceability, versioning, reuse, and product line engineering. This is especially true when designing large, complex systems or systems that follow standards and regulations. So most modern requirements tools do a decent job of capturing requirements and related metadata. Some tools also support rudimentary mechanisms for baselining and traceability capabilities, linking requirements. The early version of IBM Doors Next supported rich configurable traceability and even a rudimentary form of reuse. Doors Next became a complete solution for managing requirements a few years ago when IBM invented and implemented Global Configuration Management. We call it GCM, as part of its engineering lifecycle management, formerly known as Collaborative Lifecycle Management, or simply CLM, this suite of integrated tools. Our presentation today should take about 30 to 40 minutes, and we've allotted 5 minutes at the end for questions. So the presentation focuses on how global configuration management changed and enhanced the way we manage requirements. And again, my name is Peter Lucky, and I'm a senior solutions consultant with the 321 Gang. So on the surface, if you've looked at GCM, it seems like it just provides a versioning capability, but it is so much more than that. GCM arms product/system development organizations with support for advanced requirement reuse, traceability that supports versioning, release, and variant management. And it's also possible to manage collections of related application lifecycle management and systems engineering artifacts in a single global configuration. Now let's get back to basics for a minute. The fundamental organizing construct for IBM's engineering lifecycle management applications before GCM was a project area. Within a Doors Next or requirements management project area, the fundamental construct used to manage requirements is a module. In our example, there is a team of engineers managing a set of requirements for a product which is made up of hardware and software elements. Before GCM, project areas were the only containers available for organizing this data. Project areas can support only one stream of development. With only one stream, it soon becomes chaotic for a team to coordinate and manage the requirements, even using modules. We also might need to develop variants of the product and or maintain multiple releases of the product simultaneously. That is also very difficult with only one stream. So in each of the ELM application, teams perform their work in the context of project areas. A project area defines the product deliverables, team structure, process, and schedule. You access all project areas such as iteration plans, work items, requirements, test cases, and files under source control within the context of a project area. When you click on the hamburger, so let's click on the hamburger, it reveals a list of the project areas where you are a member. The 3 highlighted project areas are a part of a lifecycle project. The requirements management project area, JKE banking with the RM at the end, the change and configuration management project area, JKE banking with the CCM on the end, and the quality management project area, JKE banking QM. Selecting the JKE banking RM project area displays the project dashboard. We're not showing the dashboard, we're showing a step inside there. So we click on the artifacts up at the top, and we see all of the file folders and the artifacts that are in this particular file folder, because that one's selected. Then we come over here to the gear and click on that, and that allows us to see how we might manage the project properties, the details of this project area, and manage the project area. So this is where we talk about roles and permissions, and it's also where we would go to enable configuration management. Now, GCM changes the game. So let's look at a simple example of that. So we will still be working in a single development stream. Now, whenever an engineer makes a set of changes, including adding new requirements, the edits or changes are remembered in the change set. The change set allows us to deal with a set of changes as a unit. Once the initial changes have been completed, we can create a baseline. This would allow us to perform a formal review, like an SRR, on the frozen set of artifacts. After a review, then we would probably do fixes again using change sets, and we can move this into the design phase, which will most likely create other requirement changes. And optionally, we may create another baseline at this point. New modules may be introduced to the managed requirements at the subsystem level as the system is decomposed into hardware and software elements. So more change sets. And change sets will again be used to do this. When the subsystem specifications are ready for the preliminary design, we will create another baseline, perform a formal design review, and continue on in the process. Now, we could apply this same pattern while using an agile development method, creating a baseline at the end of each sprint or iteration, but still using change sets to make the changes within the stream. Now, once we go and enable application local configuration management, that together with global configuration management allows for the use of components. Now, components are contained within project areas and provide a more granular container for organizing artifacts and new configuration management constructs. These constructs include streams, baselines, change sets at the global level. both at the local and global level. So components can be used to organize requirements either functionally, logically, physically, or some combination of the three. So each of these components will start with one stream used to manage its requirements. Each component acts as a mini project area, allowing us to focus on one of the components at a time. Each component has its own team working on the artifacts in the component stream. Now let's take a step back and look at a single component. That we're in the context of a project area, we're looking at a single component. So once the configuration management is enabled for a project area, a component is created. When using configuration management, a component like a project area is the fundamental organizing construct for the engineering lifecycle management applications. A component encapsulates a collection of artifacts and is treated as a single configuration item within a project area. A stream within the component is a read-write configuration of a component. Now, in the context of a component, a configuration, whether it's a stream or something else that we're going to see in a minute, contains a single version of each of the artifacts in the set of artifacts managed by the component. So a stream has one version of everything that's in the component. So a baseline is a read-only configuration of the component. The baseline is sometimes referred to as a snapshot. Then let's go ahead and click. So there's the baseline. Then we have a change set. So a change set is also a configuration of the component. Again, the configuration means it has a version of every artifact that's in the component. So the change set is associated with the stream and acts as the container for the set of edits. So it remembers what has been changed during that edit session. Then we have something called a variation. So a variation is a child stream derived from a baseline. It's also known as a branch. The intention for a change set is to be delivered back to its ongoing stream once the changes are approved. So you see that. And so we can use change sets, can be accepted into other streams within the same component. So we can move the changes that were made in this stream over into the original stream if that's deemed appropriate. And so we can use this to set up a variant. Here we have a US variant, an EU variant, and a UK variant, okay? So let's take a step back and look at a single component. Okay, so here we go. Now let's take the next step. So the next step, we're going to see illustrate the structure of a project such that you know where to create and edit the requirements. So we're going to start at the project area. So here we are in the Systems RM project area. After CM is enabled for the project area, there is at least one component within the project area. So we next go into this component, and the component has the same name as the project area for the first one. And then within that component, when it's created, there is one stream. So next we want to select the stream configuration, the System RM initial stream, and let's take a look at that in a little more detail. So here we have a stream that's been worked on for a little bit. It's still a single stream, and a version of the Systems Requirement Specification module, this module down here. So there is a, let's go and see, every place that you see this red circle, there is going to be a version of that module. So we edit and make changes in the module. We save those changes back to the stream. We keep that in the baseline. We make some more change sets, baseline, more change set, another baseline, and we keep going on like that, developing this module. And so really the module is the preferred place to create and maintain the requirements. Each version of a module has a versioned set of the artifacts. This is where the requirements are created and maintained. We do recommend that changes are made within the context of change sets. Now let's look at another pattern. This one is the variant stream applied at the component or local level. So there are many situations where we would like to maintain multiple variants of a product. This would be for multiple markets or for maintaining multiple releases. So we're going to illustrate using variants for multiple markets. So the starred stream from the single stream slide that we saw earlier is shown here. This product US version is the base version. So once the subsystem modules have been added to the stream and we have a baseline, then what we're going to do is create a stream off of that baseline here for the UK variant. Now this stream, when we initially create it, this right up here, is going to look exactly like the baseline, except it's read-write. So it's going to look exactly like this stream at this point in time, and it's read-write. So then we go ahead and make changes to this stream that are appropriate for the UK variant. They will be different. Everything else is the same as the US version, except for what we're changing in the variant. And we could also have a second variant. We could have a third, we could have a fourth, but right now we're just having the two. So we have the UK variant and we have the EU variant. And then we also have the US version, which is basically the third variant. This is the base variant, and then the other two are based on this. So we can go ahead and make changes in here that these changes that we're making in the US version are not included in here unless we want them, and then we will share them. Now, components can be used to organize requirements either functionally, logically, physically, or using some combination of the three. So we have the capability to break our subsystems into their parts using project areas and components and set up a hierarchy which parallels our architecture. Now, in this illustration, we're looking at a physical hierarchy. There are two project areas. The first is the product project area containing one component, the system component. The second is the subsystem A project area containing 4 components. Subsystem A, which is at the highest level, and the 3 parts that make up subsystem A. So you see the system, the subsystem, and the parts making up the subsystem. Now, to complete illustrating the original product area example, we would like to add 2 more project areas, one for subsystem B, one for subsystem C. But we're only showing the one subsystem right now. Each component still acts as a mini project area, allowing us to focus on one of the components at a time. So within the subsystem A project area, each of the components encapsulates a requirement specification module and a design module for the subsystem A, or one of the parts that make up subsystem A. In just a few slides, we're going to illustrate how this looks within the GCM context. Up to this point, we have only for requirements management. Even when focusing on requirements management, there are many situations where we want to connect to test assets maintained within Engineering Test Manager and source code maintained within Engineering Workflow Management, and possibly work items or model elements contained in other applications. So if we were to work only with project areas, we would create a lifecycle project made of the system RM, system QM, and system CCM project areas. But as the project gets more complex, we want to start using global configuration management and thus components. So the 3 regular components on the slide were derived from the 3 project areas we just mentioned. We then create a cross-domain global configuration component, which virtually encapsulates the RM, QM, and CCM components, allowing us to associate the right version of the requirements with the right version of the test assets and the right version of the source. So you see how it would look inside GCM. We have a global configuration stream which is the main stream in a global configuration component, and that has 3 streams in it, 1 for each of the components inside here. Now let's look at a global configuration component itself. The global configuration management concepts parallel those of local configuration management. So when using global configuration management, a GC component is the fundamental organizing construct for managing a set of components. A GC component virtually encapsulates a collection of component configurations and is treated as a single version of a set of components. So that's a GC stream. A GC stream is a collection, read-write, of these component configuration streams. A GC baseline is a collection of read-only component configurations, so they need to be baselines within the individual components. And then a personal stream is a version of a GC stream containing a collection of component change sets. So thus the parallel between the 2 kinds of components. And then a GC variation is a child GC stream based on a GC baseline, also known as a branch. And the intention for the personal stream is just like the intention for the change sets, but it's to provide the global configuration that holds the change sets that will be delivered back to their originating stream once the changes are approved. And so here we have the EU, US, and UK versions or variants of the global configuration component. Now this illustrates just a little bit different in perspective. Here we have the global configuration component, the global configuration stream. We have 4 different components here for DNG, RMM, RTC, and RQM. So these are the version 6.0 terms for these. In 7.0 they get different names, but it's still the same idea. And so we have the GC stream originally pointing to one of the streams in each of these components. And if we have a GC baseline, it's going to point to one of the baselines in each of these components. And then we have a third way of looking at things. So here we create a GC staging stream. So sometimes we want to create a baseline for the global configuration component, but all of the baselines aren't available yet. So we create a staging stream. And then as the baselines are available, we would move this up and point it to the baseline. So when that one's ready, okay? And when all of them are ready, then we convert that staging stream into a GC baseline. So that's just another thing we can do here. Now on this slide, we're illustrating how global configurations facilitate the management of the parts virtual hierarchy. So a global configuration component in this picture and in a lot of the pictures is illustrated with the gold border. So if you see a gold border, you realize that's a global configurations component. The system GC component virtually encapsulates all of the components which make up the product. So here's the outside. It encapsulates the whole product. At the top level, there is one regular component, the system component, and one global configuration component, the system subsystems GC component. At the second level down, there are three regular components. So here we're looking at the system of subsystems GC component. So there are three regular components and three global configurations components. And then at the third level, we have three global configuration components that each include three regular components that are for the parts for each of the subsystems. Okay. Now, this slide illustrates three levels of hierarchy, but using these techniques, we could set up a many-tiered hierarchy. Any regular component virtually encapsulated in a GC component can communicate with any other regular component in the same GC component, whether nested or not. So that means we could have a link from part C3 to the system component if that's what we wanted to do. This is how it looks within the tool. This is how we would set it up. So we have at the very highest level, we have the system RM initial development stream. This is inside the system RM component. And then, so at that, we have the system initial development stream here at level 1. And under that, we have a regular component and a global configurations component. Then at level 2, we have the stream. And inside that, we have 1, 2, 3 regular components and 1, 2, 3 global configuration components. Then we step inside this global configuration component and we have 1, 2, 3 regular components. Now, we touched on some of the usage patterns earlier in this presentation as they applied to a single component. Now let's talk about each of the patterns in a little more detail. So there are 4 primary usage patterns that we're going to talk about. A single stream component, and we've really talked about that in a bit of detail already. A variant stream component, we've introduced that. And then we'll talk about, and let's sort of do that, and a GC stream with a component hierarchy. And then a GC stream with cross-domain components. So we'll talk about each of those 4. And we're going to use this model to illustrate the 4 usage patterns and then show how these patterns may be mixed and matched by putting it all together. So there are 3 single stream requirements management components: system RM, process RM, and standards RM. There is one variant requirements management component, variant PF. So that's going to have multiple streams in that. All the RM components, let's click again. All the RM components are also set up as cross-domain components, but we're just going to be highlighting one of these, with the cross-domain components. And then there are 2, these right here, there are 2 non-requirements management cross-domain components, the system QM and the system CCM. So in addition, we have a project area here. And inside the project area are 5 RM components shown on a later slide. And this will be used to illustrate the GC stream and component hierarchy pattern. Okay. Now, first, the single stream component. And this we saw. So each of these 3 components pictured followed by the single stream component pattern. are following that pattern. Each of these components is the initial component derived directly from the project area. The system RM component stream is illustrated below. So you'll see that right down here. Okay. So all the work is performed in a single stream, and we're advising using change sets to capture these changes. And for these three components to communicate with each other, they need to be included in the GC component. Okay, so if these three need to talk to each other, they're going to be included in a component. Now let's look at the second pattern. A variant component pattern is used to build and manage variants of the initial stream. So start out with the product initial stream, and then we use, as we talked about before, change sets to add in the base or reusable requirements. Then we create a baseline from the initial stream. Then we create a variant A product, and we use change sets to make changes, unique requirements for variant A. We create a baseline for variant A, and then we're going to repeat the same steps here for our variant B. Okay, whoops, let's go back to that so you can see that a little longer. So we have three variants again, we showed that before. Now let's look at the release or maintenance variant. It's just a little bit different. We start again with the product initial stream. We use change sets to add in the base or reusable requirements for the first release. Create the baseline. Then we create a stream for the development of release 2. So release 1 is continuing on. We have a baseline, so we'll probably release that, and now we're doing maintenance on release 1, while we've created release 2, where we're going to make some changes in there, and we'll create a baseline in there. Once we're ready for releasing release 2, we'll create a stream for release 3, do some changes in there, and so on. And ready for release 3. Then we might come back and we had to do some maintenance on release 1. So we used some change sets, made some maintenance in there, and we realized those things that we did to maintain release 1, we want to share in release 2. So we just share that change set with release 2. All right. Here the changes are accepted from release 1 stream to the release 2 stream. Our third pattern is a global configuration stream with a component hierarchy. So a gold box outline with rounded corners, again, designates the global configuration component. The red box outline with square corners designates a requirements management project area. So there are two GC components, with one virtually inside the other, showing the hierarchy. The RM system of record, initial development GC stream, is shown in the illustration below, containing the product components in the other stream. All that's saying is this is what you would see in GCM that represents the picture that we're seeing over here. All right. So we have two tiers again with the two components, and this is virtually tier 2 is virtually inside tier 1, even though it isn't physically inside it. The fourth pattern is the global configuration stream with cross-domain components. So putting cross-domain component streams in a GC stream allows the components to support cross-domain links. So we can link from requirements to test cases. We can link from requirements to source code, or test case to source code, and those kinds of things. So the cross-domain initial development GC stream is illustrated at the bottom, again over here. So let's look right here. So we have one GC component. It has two requirements management streams, and quality management stream, and a source code stream in here. And so you can share links between anything in here. So it keeps the right version of the stream that works with the right version of requirements, with the right version of quality management stuff, with the right version of source code. Now, here's just a slight difference, and that you really see when you look inside here, because before we had a stream in here, now we have a baseline in here. That's just saying the requirements have been baselined. And we want to make sure when we're developing our test cases that we're testing against baselined requirements. And that when we're developing the source code, we're developing against baselined requirements. So this is a slight difference in what's in the global configurations component as to the previous one. So here we have the 4 primary usage patterns are used in this system. So this is the same grouping that we had earlier on. We have the process component and the standards component are grouped together in this global configuration. We have the variant component right here, and the 3 cross-domain ones in this configuration. And then this project area has a single component in it that has nested components in it that are put together using global configurations. So we're using all the various types of things in here. These are single stream, this is a variant stream, this is a cross-domain, and this is a hierarchy. So we have all of the things illustrated in this one system. Okay. There we go. So I was supposed to point them out with the circles as we went through that. So in conclusion, CM, configuration management, and global configuration management are game changers for requirements management. GCM has transformed IBM's Doors Next to support enhanced traceability and reuse, as well as versioning and the core capabilities of product line engineering. So we are at the end, and wondering if you have any questions that you would like me to answer at this time.
Yeah, so please just type them in the question box in your control panel, and we do have some, Peter, so let's get started. So the first one, what are the questions to ask oneself when deciding to break a project out into components? We do have a customer document, system spec, and software spec. However, the system we are building is made up of many moving pieces, some of which are part of the base platform and others that are features. And it seems like it would be better to make use of components with this latter breakdown.
Yeah, I mean, that sounds like a perfect example for using a component breakdown of your system. And what it does, I mean, using just what you were talking about. So you start with the platform, and then you might have parts of that platform. I mean, we would want to know whether this is a hardware and software system or it's all software. Because if it is a hardware and software system, many times you want to break it down, so you break it down by the hardware pieces. And do it physically that way. And so you have a component that surrounds that hardware pieces, and the software would be part of that component. The software that runs on that hardware would be part of that component. There are other times that you might break it down functionally, according to the appropriate functions. But that's the kind of thing that we do when we get together with a customer, is we have a big whiteboarding session where we talk about all these different possibilities and try to figure out for you what's the best breakdown. We don't want to introduce too much complexity early, but we want to make sure that we're really addressing the appropriate issues. Okay? Is there another one?
Sorry, Peter, I was on mute. Can you recommend how to cleanse a stream if you are starting from a monolithic single stream implementation, but want to start using the multi-stream approach?
So could you read the first part again?
Sure. Can you recommend how to cleanse a stream if you are starting from a monolithic single stream implementation, but you want to start using the multi-stream approach?
So essentially what you're doing is in Doors Next terms, if you're starting to use just the project area, then typically you're going to be breaking that project area up using your folder structure. And so that gives you a hint on how do you want your components broken out. And then there are tools within Doors Next that allow you to basically create a component and take the stuff that's in a folder area or a section there and actually migrate it into the component, and then you delete it from the folder structure, and then you can manage that section in the component, and you can do that with as many of the sections that you want to. So that's how I would do it.
Okay. This is just a comment from one of your colleagues saying that they're excited for the new release. It's coming out later this year, and that users can edit the RM, QM, CCM boxes to label them better. So that was just more of a comment.
Yeah, that'll be nice. That'll be nice.
Yeah. And then another one saying you're doing a wonderful job laying out GCs, which is also nice. So how do you conduct reviews of change sets before they, excuse me, I went on to another line here, before they have been merged into a stream?
So here's what my advice is relative to that, is that change sets are meant to be relatively small. So I recommend that a change set is work done by one person making changes in no more than a day. Maybe even a half day would be better, but no more than a day. And when that change set is completed, what I really recommend here is, because if we keep them small like that, then you do a peer review. So you have a peer come and look at that just for that kind of thing before you deliver it back in. Now we can set up formal reviews of that kind of stuff. Unfortunately, the formal review mechanism within Doors Next does not work on a change set and the doing things there. So there are ways to get around that and so on and so forth. But what I would really recommend is keeping your change set small and then using the review process, peer review. Now, one other thing you can do is set it up so that a change set must be approved. So you can connect it up to a work item, have it go through the process of the work item, and then the work item has to be approved before that change set can be delivered. So that can ensure that somebody has at least looked at it to approve it before it goes back into the stream. Okay. Sort of a convoluted answer. Go ahead.
So this one has two components to it from the same person. It's a little bit long, so I'll ask you the first one, and then we'll go to the second. So it says lots of familiar clear case UCM terminology. So wondering, does GC have same process steps like rebasing of a personal stream before introducing change set modifications into the baseline?
No, I do not believe that is included in there.
Okay, and then it says same question with respect to creating composite baseline across multiple components that can be recommended as the current baseline to rebase to or start a new stream from.
Yes, essentially you need to, if you're starting a global configuration stream, you need to do that from a baseline of the global configuration component. And the only way you can have a baseline of the global configuration component is to have a baseline for every stream that makes up that global configuration. So each one of those has to be in a baseline state before you can declare that that's a baseline and create a new stream off of that.
Okay. Can you create a change set that includes changes across components?
Yes, yes, and that's what the personal stream is.
Okay. Well, it looks like that might conclude the question portion. I think we are all set unless anybody has anything last minute you want to type in. Otherwise, I'm going to go ahead and wrap things up. And we wanted to let you know that this session was recorded and it will be available for playback at 321gang.com under our resources tab. We'll have that up by the end of the day tomorrow. So if you have any more questions or think of something after we end the webinar today and we're interested in hearing more about the IBM tools and 321gang's expertise, please email us at info@321gang.com. So Peter, thank you so much for your presentation. It was great.
All right, thank you. And I'd be glad to talk with any of you going forward about any of this. So thank you very much.
All right, thank you all for attending. Bye-bye.